All right, let's talk about these last couple pages. So this page here about horizontal and vertical lines. Um, okay, so just the concepts behind them. So a horizontal line is obviously a line that looks like that. That's horizontal. So if you imagine the slope of a horizontal line as the rise over the run, then you can see that it's not going anywhere vertically. So the rise is 0 no matter how far the run is. So say I was going from 0 to 10 here. Okay, so the run, you can keep going horizontally in any direction on this line, but you're never going to rise at all. The rise is always going to be 0, so that means the slope is 0. Okay, so that's a horizontal line. A vertical line is a little bit weirder. Like in terms of how we describe the slope, it's not that weird of an idea. So a vertical line is obviously one that looks like this. Okay, so it goes straight up and down. So if I'm thinking about the slope of a vertical line in terms of rise and run, then I might be going, say I'm going from 1 to 7 here. I might go up 6, but my run is 0. I'm not going left or right at all. I'm only going up or down. Okay? So in math, when we have a situation like this where we divide by 0, we call that undefined. Okay, and this is like kind of a higher level math concept, but basically the idea is that you can't know the answer if you're trying to divide by 0. Okay, and that's what undefined is telling us. So a vertical line has an undefined slope. Okay, so that sort of covers the top concept part there. Graph the following lines. So then it gives you these equations of lines that are a little bit weird. The first one, y equals 4, and the second one, x equals -5. So if I go back over here, so here's my Cartesian grid, y and x. And get another color going here. Okay, so if I have y equals 4, like it says right here. So I'm going to find that on my axis here. That's 4, okay? And basically what that equation is telling me is that it doesn't matter what x is, y is always 4. So I'm drawing a straight horizontal line through 4 on the y-axis. Okay, so when you see an equation that looks like this, y equals some number, that's always the equation of a horizontal line. Okay, and then if you're asked to do some analysis of that, the slope of a horizontal line we set up here is always 0, and then the y-intercept is just whatever number it equals. So in this case, it would be 4. Okay, the other line you're given there, x equals -5. So that one, I'm sure you can guess by process of elimination. If I found -5 on my x-axis, then that's just what that equation is telling me is that x has to be -5 and y can be anything. So that means that I've got a vertical line passing through -5 here. Okay, and so the equation for a vertical line always has this format, x equals some number. Okay, and then if you have to do some analysis of that one, we already talked up here, the slope of a vertical line is undefined. Okay, and it never hits the y-axis, so it doesn't have a y-intercept. Okay, so undefined slope, no y-intercept for a horizontal line, or sorry, for a vertical line. All right. All right, so the next task you're given here is you're given a pair of points. You're asked to plot them, connect them, and then please disregard that text message that just popped up on my screen. You're plotting the points. You're going to connect them with a straight line. Use a ruler or some sort of straight edge. Hopefully you have something like that lying around. Determine the slope from the graph. Determine the y-intercept from the graph. And then write the equation in the form y equals mx plus b. So I'll do one of the examples for you, and then I'll leave the other one for you to try on your own. Okay, so let's flip back. I'm just going to write down the coordinates of these points. So we've got -2, -4, and 1, 2. Okay. You know what? I'm gonna graph this on a graphing calculator called Desmos. You could choose to do the same thing if you don't want to do it by hand, just because I don't have nice grid paper to do it on. So I'm just gonna cheat slightly. Okay, so I'm plotting my first point, -2, -4, and then I've got 1, 2. Okay, so that's these 2 points here, -2, -4, and 1, 2. Okay, and then I want to connect those 2 points with a straight line. Is there a way to do that here? Okay, so I got a line to connect those 2 points, so now I can do a little bit of the analysis I need to do. So I can see my axes are a little bit different than yours, but I can see that if I go between, I could go between these 2 points, or I could pick any 2 points on the line to figure out the slope. So let's say I'm going from this point right here, -2, -4, to this point right here, -1, -2. And to go between those 2 points, I'm going up 2 and over 1. So my slope is rise over run, which is up 2 and over 1. And I mean, I kind of picked 2 random points, but you could pick any 2 points. So you could say, oh, I'm going up, what is this? Up 6 and over 3. Okay, so up 6 here and then over 3. And that's still going to give you that same slope. Or I could say, oh, I'm going up 2 and over 1 here. Still the same slope. Rise is 2, run is 1, or some multiple of that. Okay, so my rise is 2 over 1, which is the same as just 2. My y-intercept here, so that's my b value. Oh, there we go. My b value. So you can see the line here passes through the y-axis at 0. So my b value is actually 0. B equals 0. Okay, so then to write the equation of that line, y equals mx plus b. Okay, so I can put in the specifics here, y equals 2x, and then I don't need a plus b because b is 0, okay? And I don't need to write plus 0. Everyone knows that doesn't change the value. Okay, so that's my answer for A. Okay, next page. Graph a line with a slope of 3 over 4 that passes through the point A to -1. So I'm just going to kind of describe to you how you might do that one. So you are going to plot this point to -1. So if you labeled this axis as like each grid square equals 1, then to -1 would be 2 right here, and then -1 right here. So you'd put point A right there. And then to get more points on the line, you're going to use the slope as sort of direction. So starting from point A, you can go up 3, a rise of 3, and over 4, okay? And that would get you another point right there. Or oh, sorry, 2, -1 would be right here if you were using it. I was thinking of a different scale here. So up 3 over 4. Sorry, so 0.8 would be right there. So up 3 over 4 would give you another point right here. And then you can see that you kind of run into space. You can't go over 4 again from there. So another way to find points would be to go backwards instead. So instead of going up 3 and to the right 4, we could go down 3 and to the left 4. And that would give you another point on the line there. Okay, and then you just use a ruler to connect them. Same idea here. You're going to plot your point, and then you're going to use this as rise over run to figure out another point or two on the line, and then you can connect them with a ruler. Okay, these hopefully pretty easy. Just reminding you that the equation of a line is this. So if I'm giving you m and b, you just have to write y equals and then swap out the m for whatever number I told you and swap out the b for whatever number I told you. Okay, calculating slope. So this is kind of important, so I'll start a fresh page and I'll show you how to do one of these. Okay. I'm just going to write down the coordinates before I flip over to that other screen for 5 and B 6, 9. Okay. So we think of slope as rise over run. Okay. But if we are just given coordinates like this, it can be easier to put that in more algebraic terms. So y2 minus y1 over x2 minus x1. Okay, and this right here, it means the same thing as this. It's just how much are you changing in the y, so in the vertical direction, which is the same as the rise, and how much are you changing in the run, the horizontal direction. When I'm doing this though, because it's kind of like a process, I find it easier to label my points. So point A, I'm going to say that this is x1 and y1. And then point B, x2, y2. And then that'll just remind me where to put the numbers in my equation. So y2 is 9, y1 is 5, x2 is 6, x1 is 4. So I've got 9 minus 5, which is 4. And I've got 6 minus 4, which is 2. And if I simplify that, it gives me a slope of 2. Okay, so my slope for that one is 2. Okay, and then you've got a second question, very, very similar. Use the same labels and things, and you should get the right answer. Okay, and then this last one turned on its side. So these are good. Oh, I see. Okay. So let's see if I can quickly do one of these examples for you. And then you can try the other one. I'm going to run out of time on this video, but I'll try to talk fast. Okay, so we've got slope is 3 over 4, and you're passing through the 0.85. Okay. Okay, so y equals mx plus b. Okay, so in this case, you know the slope, 3 over 4, and you are given one pair of coordinates on the line. Unfortunately, that's not the y-intercept, so I can't just put a number in here. So I'm going to use these values of x and y to figure out what b has to be. So what that looks like, I'm going to put my y value in there. I'm going to put my slope in here. I'm going to put my x coordinate in here. And then b is the only thing that's left as a variable or a letter. Okay, so I can solve for that. Okay, so 5 equals 3 over 4 times 8 is 6 plus b. So then I'm going to bring the 6 over to the other side. I end up with -1 equals b. So the equation of my line is y equals 3 over 4x minus 1. Okay. Whew. Just made the 15-minute cutoff on this video. Hopefully that's enough to get you through those last few pages. Keep up the good work.